We're going to begin talking about slope. And what we need to be able to do, if you look at the outcome that you're supposed to be able to satisfy at the end of all these videos, we're going to do a series of them on slope, is you need to be able to demonstrate an understanding of slope with respect to rise over run, line segments and lines and all that stuff, and then parallel and perpendicular lines. So just as an example, if you look at these three roofs, I think you can probably see that one is steeper than the other. And then as you kind of put a grid over top of them, you can actually measure the steepness or the slope of the roof. That's what slope really means. The idea is just figuring out when you run, meaning you go along the x-axis here. If I go along here, that's called the run. Okay, you can see that in yellow, but it's a little hard to see, so I'll fill it in. And then you're going to rise. You're going to go up a certain amount. Okay, so as you run a certain amount, in other words, as you go horizontally a certain amount, you're going to rise a certain amount. You're going to go up a certain amount. And measuring the ratio of that will tell me how steep it is. In other words, how quickly do I rise when I run a certain amount? That's the idea. Okay, so if you look at this and you just count the blocks, let's say I start here. I go 1, 2, 3, 4, 5, 6. And then I go up 1, 2, 3, 4, 5, 6. So basically the rise over run here is 1. Okay, 6 over 6. If I do this one, I just go 1, 2, 3, 4. I'm rising 1, 2, essentially 2 and maybe a little bit. But that means the slope is 2 over 4, 1/2 here. And this one, if I start here, that's 1, 2. I rise 1, 2, 3. So the slope here is actually 3 over 2. Okay, so this one, the slope's 1. That's 1/2, and that's 3 over 2. And I think you can see the difference in the steepness. Okay, so the idea of slope is rise over run, and it's the idea of taking the vertical distance that you've moved from the bottom of the edge of the roof to the top, to wherever you stop, and the run is that corresponding horizontal distance. That's the idea of slope. So when we talk about slope, you're actually going to see it in 3 different forms. Okay, and you might recognize delta as the change in, so you sometimes will even see it like this. But the rate of change, or the slope, is the change in y over the change in x. So we call it the rise over the run. That's one way to say it. We call it delta y over delta x, or change in y over change in x. That's another way to say it. And then thirdly, to sort of describe the change in y, we write it like this. So this is more of the computational formula. This was actually what we're going to use, because we're going to identify 2 points. So let's say I identify that point and that point. Okay, then I can say this is 1, 2, 3, so -3, and then 1, 2, it's -2. And then this point up here is 1, 2, 3, and 1, 2, 3, so it's 3 and 3. Okay, and if you look at those 2 points, you'll then label them. So what you might be wondering, what's y2 and x2 and all that sort of stuff. So we'll just call this one the first point, so x1 and y1, and we'll call this the second point, so x2 and y2. Okay, so you can find this by looking at the rise over the run, and if we just count it, I'm just going to show you this. We would go, the rise is 1, 2, 3, 4, 5. Over the run, which is 1, 2, 3, 4, 5, 6. So the slope is 5 over 6 that way. If I use the sort of computational formula, it would become y2 is 3 minus y1, which is -2, over x2, which is 3, minus x1, which is -3. And we get 3 plus 2 then, because it's minus a minus, and we get 3 plus 3 because, again, it's minus a minus. And so if we add those together, we get 5 over 6. So there's a couple of different ways to find the slope. Okay, rise over run, or change in y over change in x, and then the computational formula. The difference is, you might be wondering, well, who cares then? If I have 3 different formulas, why do I have 3 different formulas? Why can't I always use rise over run, for example? And the issue is only what information you're given. If you're given a graph, with a grid on it, you can count. I would strongly encourage you to do that. Just do rise over run. But if you're only given points and you're not given the graph, that's when the third option becomes important. So if you're given the graph, you can calculate the slope, and I would encourage you to by just counting rise over run. But if you're just given 2 points and you're not given any other information, you can use the slope formula without having the graph. So that's really the idea or the distinction between them, why you might want to use one instead of the other. Okay? So this is kind of just saying what I just said. So if you have the graph, just count. If you don't have the graph, you just have points, then you want to use that. And actually, this and this are really the same thing, right? The change in y is the rise, and the change in x is the run. So we say we rarely use it. We really don't use it because we're using it here. In other words, these are really the same thing. They're just a different wording, okay? So in terms of what's going to happen for slope, there are 4 possible slopes. There's 4 possible results that you can get when you do rise over run, when you count, or when you do y2 minus y1 over x2 minus x1. You can get a positive slope, meaning you're going to get a number that's positive. And if you do that, it's going to look on the graph like this. It's going to rise to the right. So that as x gets bigger, y also gets bigger. You could have a negative slope. And all that means is that it's going to fall to the right. It's going to go down to the right. Meaning that as x gets bigger, y gets smaller. All right? You can have a horizontal slope. And when you have a horizontal slope, what's going to happen is you're going to have a 0 divided by a number. In other words, the y values don't change. Okay, and 0 divided by a number is then just 0. So you can have a 0 slope. That is possible. And the formula then always looks like this, something like y equals 3. Okay, or in this case, if you look 1, 2, 3, 4, this is actually the line y equals 4. So horizontal lines are always y equals whatever the number happens to be. And then you have vertical lines, and vertical lines are similar, except it's the x value that stays the same, and so you have an x equals. All right, so you have this in this case, 1, 2, 3, 4, x is equal to 4 is my equation. And the slope is going to show up as a 0 on the bottom. And you should know mathematically that it is not allowable to divide by 0. If you divide by 0, then you're going to get an infinite result, and sometimes you're going to have an undefined result. So you need to know that, because when you do rise over run, in other words, if you look at just points, like on the graph, it's pretty easy to recognize a horizontal line or a vertical line. But if it's not a graph, then you have to recognize it by looking at the y values are staying the same or the x values are staying the same. So you're going to get 0 either in the numerator or in the denominator. Okay? So that's the idea behind slope, right? And you can check out this video on Slope Dude if you want to get a little more interactive way of looking at it. You can pause the video and do that. But we're just going to look at determining the slope. So if we're given the graph, we want to do rise over run, okay? And slope, we said previously, I don't think you saw it on the slide, we identify it as m. So we're just going to go rise over run. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the run is 10. And then the rise is 1, 2, 3, 4, 5, 6. So the slope is 6 over 10, and then we just reduce that to 3 over 5. Okay, so it's a positive slope for that one. For this one, our rise is actually negative. We're going down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our slope is going down 10. So we're going to say minus 10 over our run is 1, 2, 3, 4, 5. So it's minus 10 over 5, which reduces to minus 2. So the slope for the second one is negative, which we expected because it's going down to the right. And it's minus 2. Okay? Now, the flip side of this is, okay, now I have to draw a line segment that has a following slope. So instead of getting the slope from the graph, I have to make the slope on the graph. So it tells me to start at 0, 0. So I'm going to start here. And then remember, this is my rise. And this is my run. So what I'm going to do, I'm going to run 1, 2, 3, 4, 5. okay? And then I'm going to rise 1, 2, 3, 4, 5, 6, 7. Okay, so those are the 2 points that I'm going to draw a line through. And I'm going to actually use the functionality of this to draw a line through those points because it's going to make it perfectly straight. But you can use a ruler to make it as straight as possible. And you should put, because this continues forever, okay, we should put on the start and end arrows. Okay, so that's what it's going to look like. Now, minus 3 over 8, same idea. I'm not sure how well you can see that grid. Hopefully you can see it. But if we draw this, we're going to start here at 0, 0. We're going to run 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then we're going to rise minus 3. 1, 2, 3. Okay. So we're going to go there. Now you might be saying, well, how come you ran 8 this way and rose down? How come the rise was negative? And the answer is it really doesn't matter. So in other words, I could make it negative 8. So I could run backwards. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I could have went back to minus 8 and rose 3. So 1, 2, 3. They are all along the same line. So the issue is only that one of them is negative, not both. Okay, and then if I draw my line in here, whoops, grabbing the wrong thing. There we go. Then there's my line. And again, I should put arrows on the ends of it. But you look at those 3 points and they're all along the same line because you can choose when it's negative to either run negative and rise positive or rise negative and run positive. It's up to you. Okay? So that's how you draw them. Now, what happens if you're just given 2 points? So this is where we get into the x2 and y2 stuff. All right, so what we're going to do is we're going to label these points. So I'm going to call this one x1, y1. And I'm going to call this x2, y2. So the slope is y2, which is 10, minus y1, which is 3, over x2, which is 4, minus x1, which is 2. Okay, so 10 minus 3 is 7, and 4 minus 2 is 2. So my answer is 7 over 2 for that one. Okay, if I do this guy, same idea. This is going to be x1, this is going to be y1. This is x2 and y2. So all we're doing again is subtracting the y value. So minus 7 minus 3, and then divided by 5 minus 2. You just have to be careful with your negatives because it's x2 minus x1, but x1 is negative. So that's why I'm writing minus 2. Okay, so minus 7 minus 3 is minus 10. 5 minus 2 is 5 plus 2, so it's minus, sorry, not minus, it's positive 7. So my slope is minus 10 over 7. All right, if we do this one, we have x1, y1, x2, y2. So our slope is going to be 6 minus 5, y values, and then minus 7 minus 3. So 6 minus 5 is 1, minus 7 plus 3 is minus 4. And then finally, we do this one. We have x1, y1, and then x2, y2. So we go, the slope in this case is 15 minus 7 over 7 minus 5. So 15 minus 7 is 8, and 7 minus 5 is 2, and 8 divided by 2 reduces to 4. So that's my slope there. All right. So what we're going to do, we're going to stop there, and I'm going to get you to practice these questions out of your textbook.